Okay, well, welcome back, everybody. There's a slight change in the schedule, and I'll be moderating this this next session today. So, as you can see on the screen, there is 3 questions which have been posted, and these are the questions which we want the breakout groups tomorrow to be addressing. I won't read them out, but I think we'll share these again tomorrow, either first thing or during the break, so that everybody's prepared for going into the breakout rooms and for discussing then these points. Okay, so with Mikhail's talk, that was the last of the presentations presenting the emissions data sets themselves. We now move on to presentations looking at intercomparing the different emissions data sets, and we're going to start with Wenfu Tang from NCAR, talking about the intercomparison of global fire emissions for multiple species. So Wenfu, you're sharing your screen. Very good. We can see your screen, not yet in display mode. Okay, so it's in presenter mode, so please go ahead, Wenfu. Thank you.
Okay, can you hear me okay?
Yes.
Cool. Hello, everyone. I'm Wenfu Tang. I'm a project scientist at the Atmospheric Chemistry Observations and Modeling Laboratory, ACOM, at NCAR. And today I will talk about the intercomparisons of global fire emission inventories. Before I start, I'd like to acknowledge my co-workers, Rebecca Buckles, Louisa Emmons, and Christine Widmeyer, who also contributed to these comparisons. So these are the emission inventories that I'm going to compare in this presentation. So we compare 3 different versions of FIN, that is fire inventory from NCAR, and the 3 versions are FIN version 2.5 MODIS plus VERS version, FIN version 2.5 MODIS only version, and FIN version 1.5. This is also only use MODIS. And together with GFED, FEAR, GFAS, and QFED. So most of these inventories have been nicely introduced and described yesterday, except FEAR, which is fire energetics and emissions research. So I put a reference for this emission inventory and a short description from this paper. So it is FRP-based inventories. So it says it's a global graded emission product based on a top-down approach using coincident measurements of FRP and aerosol optical thickness from the MODIS sensors on board Terra and Aqua satellites. I want to these among these inventories to be compared, FIN and GFED are burned area based, while FEAR, GFAS, and QFED are FRP based. So before we get into the comparisons, I want to point out that we did not compare all the available fire emission inventories, and these 5 emission inventories are only a fraction of the available global inventories. So we in this presentation, we will look at the global total as well as regional emissions. There are 14 regions defined on this map following the methodology in Giglio et al. 2010 paper. And these 14 regions I'll pause here for a few seconds for you to look at. I'm sure you are familiar with this, but all right. So let's first look at the CO emissions. Here, this figure shows the time series of CO emissions from 2012 to 2019, and the first panel is global, and these are the rest panels are for different regions. So if you look at these time series, in general, the year-to-year variabilities in the annual fire emissions are consistent between these different emission inventories. However, the magnitude of these inventories can differ significantly. And this slide shows the annual total emissions averaged for 2012 to 2019. This is the third time you see this figure during this workshop. So each panel is a chemical species from CO2, CO, formaldehyde, BC plus OC, ammonia, C2H6, SO2, and NOx. And each bar in the panel is emission inventory. So from left to right is fin version 2.5 models plus VIRS, fin 2.5 models only, and fin 1.5 for GFAD, FEAR, GFAS, and QFAD. Within each bar, a different color represent emissions from a region corresponding to a region in this map. So the first thing I want to say is that fin version 2.5 global emissions are higher than and even approximately double the emissions from fin version 1.5. And if you look at these two bars there, it's similar for almost all species. And the second point I want to say here is that for CO2 and CO, fin version 2.5 and FEAR have highest emissions, while fin version 1.5 has the lowest emissions. And emissions from GFAD, QFAD, and GFAS are closer to fin version 1.5. Like here. However, based on the discussion yesterday, the newer GFAD will have much higher emissions than this version of GFAD, so it will be very interesting to compare later. This GFAD is the GFAD 4S. And another interesting thing to point out is that so I highlighted formaldehyde and BC plus OC here. So for different species, a comparison across different emission inventories can have different results. For example, here QFAD has the lowest formaldehyde emissions among these inventories, but QFAD also has the highest BC plus OC emissions. Okay, and here let's look at the seasonality. So these figures here shows the average seasonal cycle for 2012 to 2019, and I didn't show fin 2.5 models only version due to the limited space. So that's a fin version 2.5, fin version 1.5, GFAD, FEAR, QFAD, and GFAS. And each the color corresponding to a region. So the first thing that pops up is that for fin, there's much higher emissions over Southeast Asia in spring, as highlighted here. You do see a peak in other inventories, but not as strong as fin version 2.5 or fin version 1.5. So as Christine mentioned yesterday, there will be a field campaign in spring next year, Asia AQ, and hopefully through this campaign, we will gain some new information that could help us to evaluate and understand more about fire emissions over Southeast Asia in spring. And the second thing is that Fin also has higher emissions over Central America in spring, and that's a pink color there, corresponding to the region here. If you look at the boreal North America, which is dark green, and that corresponding to the area there, GFED and GFAS have higher emissions over boreal North America in summer. That's yeah, and next, if you look at the light green, which is the equatorial Asia, is highlighted in this figure here. GFED and GFAS also have higher emissions over equatorial Asia. Well, not in summer, but in from August to October. So these inter-inventory comparisons were conducted as part of the analysis to develop Fin version 2.5. And if you want to know more about the details of the comparisons, please check this paper, recent paper for Fin version 2.5. So as Christine mentioned about the urban fire emissions, here I want to take this opportunity to talk about the fires in the wildland-urban interface. I want to bring this up here because I value this opportunity to talk to this set of audience, and I think this is an important topic to discuss in the workshop. Fires in wildland-urban interface are an important issue and require more research and a better understanding. And I listed a few reasons here. First of all, in WI, fire risk is relatively high, and WI fires are closer to human and properties. And also fire emissions from WI fires can be more harmful. And lastly, WI fires will become even more important in the future. So we developed a global data set for a wildland-urban interface map, and it's called a Worldwide Unified Wildland-Urban Interface. And here I'm showing the change from 2001 to 2020 of the WI area fraction. As if you look at the bar plot, as you can see, WI has been increasing in the last 2 decades in over every single continent. And this paper published recently is a very nice study. So in this study, they analyzed the fire emissions from structure burning, vehicle burning at wildland-urban interface area. So in this study, they found that emission factors for some toxic species like PAH and some organic compounds were several orders of magnitude greater than those from wildfires. So that's another motivation. Given the global expansion of WI areas and the increasing importance of WI fires, I think understanding WI fires is becoming more and more crucial to fully understand fires in the Earth system. to understand the interactions between fires and human activities, changing impacts of fires in the future, and also very importantly, to understand the fire impacts on air quality and health. So because of these reasons, in our next step, we plan to address WI fire emissions in Finn. And we welcome all suggestions and collaborations. Please contact us if you are interested in discussing these topics. And with that, I'll stop here with this, my favorite figure here. And I'm happy to take any questions.
Thank you, Wenfu. This is a very, very nice presentation, and great to start off out the intercomparison and seeing where we stand, all the different data sets relative to each other. Before I open up to questions, just to comment that talking about the wildland-urban interface and fire emissions, that at the GAIA conference in Brussels in June this year, so there's another IGAC activity, or IGAC-related activity, this was brought up as a key topic to address for emissions inventories in general, as well as from fire emissions. So great that with Finn, there's some prospects to make emissions estimates for the WUI, and maybe this across the activities in IGAC, this could be an opportunity to talk to people from GAIA to see what they're doing and how they relate to this, and where BBURNED and your work can help to make that connection. So thank you very much.
Yeah, thank you, Mark.
So I'm going to look to the questions. So we have plenty of time. So anybody who has questions, I see Terry has his hand up, but maybe I'll go to Jan-Ayof Johnson first, who's asking, in fact, Jan-Ayof, if you want to open your mic and ask the question to Wen for yourself, please go ahead.
Yes, I think both, at least Finn and GFAS are both on 0.1 by 0.1 degree resolution on a daily basis. So actually we tried to add the number of fire days, and it looked, to me at least, it looks as if the number of fire days, there's quite a good correspondence between the number of fire days and the CO emissions and the various regions. But I haven't really done a lot of checking on this. So have you tried to do something similar?
So for I can't speak for GFAS, maybe, but for Finn, so for Finn, the emissions are calculated for individual fires, and it's regraded to 0.1 by 0.1 degree in a later stage. That's also the reason why I think Finn is very suitable to look at WI fires. So for Finn and GFAS, I think they are calculated based on the actual fire detections, satellite fire detections. I don't know about the number of fire days. I think Christine can add something here, but Finn have some assumptions of the continuous fire to the second day over the equator areas, just because the satellite coverage. I think do you suggest like extend the fire duration assumption of file duration?
No, actually, we're just using the what we downloaded from the websites, and I think that was on 0.1 by 0.1 and by day, and then we simply just calculated the number of 0.1 by 0.1 grids that actually had a fire every day, and then summed up. and the numbers are quite different from depending on the inventory. But the difference was also quite similar to the CO emissions. So it looks as if could be that one important difference is simply if the fires is detected or not.
Mm-hmm. Yeah. For the calculation of burned area based inventory, I don't know if we assume we use any assumptions for fire duration, but for FRP based inventory, maybe there are fire duration assumptions for.
Yeah. So in GFAS, maybe I could just comment. So GFAS, this is what we have to do. We assume a persistence, so that if there is a cloud the next day, then it doesn't necessarily extinguish the fire straight away. But the limitation of that is that we're assuming that the fire continues until we have an observation of no fire in that pixel. So it does then lead to sort of this additional spurious behavior of the fires in the way that we've done it, because it could potentially that could persist for several days rather than we don't cut it off after 2 days, for example. Yeah.
Exactly. And it's exactly as Mark said. And I mean, the rationale behind that is that if we miss fires, we assume that we miss fires, but due to the limited detection opportunities. But then on the other hand, we extend fire duration for longer than is realistic. And that these two effects compensate each other, which both come from the limited detection opportunity. But when you look at a number of fire days in GFAS, you have to be a bit careful, because switching off doesn't mean going to zero. So it's GFAS, due to this assimilation procedure, it's dampening the fires down to zero in an exponential way. And then we have a cutoff at fire of 1 megawatt per grid cell. But when you look at histograms, you will find a tail in the distribution and with unrealistically many small fires there. So when you analyze that, you have to sort of make a smarter cutoff somewhere.
Thanks, Johannes. So I think, Terry, you had your hand up for a while. Do you want to go ahead and ask Wenfu your question?
Yes, thanks. Mostly, I just wanted to encourage Wenfu and the whole team interested in the wildland urban interface to join the HTAP Fires white paper and add some discussion there about the potential for that. And I'm wondering if we can use our model into comparison to maybe have a sort of pilot data set that we can explore the potential impacts, because this is a really important issue. For what HTAP would like to do is look not only at the traditional aerosol and ozone precursors, but to also look at metals and persistent organic pollutants and other things that are much higher from that wildland fire interface. And so if we could design some sensitivity studies based on what's already been known, we can start to look at how important those issues are at different scales. So thanks.
Yeah, thank you, Terry. Yeah, I am involved in the HTAP paper writing, and I will definitely add some WI relevant discussions there. Yeah, so WI files is not a new topic. It has been existed for in the fire management community for decades, but it's relatively new for us, for our community. I googled air pollution WI fire, and I only found a few papers focusing on this issue. But I think it's an important issue and deserve more attention.
Good, thank you. So no one else has their hands up. Let's go back to the chat. So Shoba had a question about how WUI is determined and what data is used.
Yes, thank you, Shoba. This is a great question. So WUI, if you the simple definition is where human infrastructure and wildland come into contact. But in reality, there are a few very detailed technical definition. There is one widely used one from the Federal Register 2001, and so they divide the WUI to wildland urban intermix and the wildland urban interface, and each one has a very detailed technical definition with numbers like distance from wild vegetation and house more than 6.18 house per some area. But the definition is not unified. I know in Europe they use a different definition of WUI. Yeah, so it depends on purpose. So the WUI dataset I used is there is a WUI map, a GIS map from the USDA website. If you Google WUI USDA, you'll be able to find that.
Good. Thank you. So there are still some more questions. We'll see how the answer to this next one goes and then decide. Well, with 3 minutes to go, I think we'll just take this question and then Wenfu, if you don't mind answering Xiaohua and Fang Zhun in the chats after, that would be helpful. But there is this question from Eric Roy about speculation of the source of the springtime peak in fin emissions in SEAS, and is it expected to be a result of the burned area identification or the modeling required to approximate the associated CO emissions?
This is
answer that in 3 minutes then.
I can't see anything for sure. At burned area.
1748 was the time.
Let's see.
I think it's fin 2.5.
Yeah, it also exists in fin 1.5. I don't know, it could be, Christine mentioned we do have some persistency assumption in the tropical latitudes. That might be the reason, might be part of the reason. It's hard to say for sure now, and we hope the HIQ field campaign can provide more information to look into this. So for
Okay, well, I think there's more discussion to be had maybe, but yeah, if you don't mind looking through the chats and answering those other questions. Yeah. I think we'll transition over to the next presentation, which will